Assalamualaikum warahmatullahi wabarakatuh and good day to each and everyone. So, this is Sir Hanif, your instructor in A225. Okay, so this is Engineering Electromagnetism. So last meeting, we have been discussed the basic and the basic idea about vectors and their characteristic and their applications. Okay, on different areas. So now we will go on through um, differential calculus. So once again, this is not my proper. This not my. This not. This um, manual here is not my own. No, I am not. I am not the one who produces this one. So kindly do not share this to anyone. Okay, I have just used this for uh, convenience, no, and for proper implementation of these topics. Okay, but this not I'm not the one who produces this manual here manual. Okay, so this is credited to the owner. Okay, so kindly do not share this to anyone. Okay, so we have here differential equation, differential calculus. Okay, so differential calculus. First one here is the ordinary derivatives. What we'll do here is we will be discussing about the how to perform a differential or derivatives, okay, of a certain function. So ordinary derivatives. So consider a function of one variable f of x. So the derivative df over dx tells us how rapidly that f of x varies when we change x by tiny amount dx. Okay, so has been discussed by this has been discussed from our previous mathematics, no? So how to derive and what's the physical phenomena of the derivative. Okay, so df over dx is the slope of the graph f at versus x. Okay, so you can interpret df over dx as a slope of a certain function f, okay, with respect to x. Okay, so now we will go on to gradient. No, gradient is uh, uh, somewhat like an operator that can be used in order for us to get the slope of a function that is as a function of three variables or more. So now consider functions of three variables. So for example, is x, y, a function t as a function of x, y, z. So how does t varies depends on the direction. So taking the differential of t, we have here dt is equals to dt over dz. Partial t with respect to z dx, partial of t with respect to y dy plus partial of t with respect to z dz. So this tells us how does t changes when we alter all three variables by infinitesimal displacement dx, dy, and dz. Okay. So when you say infinitesimal displacement, those change of length into a smaller part. Okay. So this equation now tells us how does uh, function t varies when we vary its parameters into a smaller variation. Okay. So this equation here is taken from the definition of the dot product. Okay. It's because if we have here a del operation, this what we call as a del operation, and a infinitesimal displacement. If we dotted that one, the result will be this one. Okay, so this is the del operation, or sometimes called as a gradient operator. Okay, gradient operator. Then we dot that one with this dl, then the result is this one. Okay, the infinitesimal displacement. Okay, so in a manipulation, you can just use del, which has a arrow sa taas, or just use this one. Okay, so if we have a function t, So we can have its gradient using this equation. Okay? So we have here del of t is the gradient of t. Okay? So let us rewrite dt as a function. Okay, so this has been discussed sa taas. So anyway, just read this physical phenomena. Okay, so dito tayo sa find the gradient of r. Okay? Find the gradient of r, which this r as a function of x, y, and z. Okay? So if we take the gradient of that using this definition here, ito, so we can have this solution. So we have gradient of r is equals to partial of r with respect to x, x hat, partial of r with respect to y, y hat, and partial of r with respect to z, z hat. So taking the derivative of this r here with respect to x, so mangyari dito kay 1 half, then yung nasa loob niya, which is x squared plus y squared plus z squared, then yung 1 half niya is subtracted by 1, so that will be negative 1 half, then multiplied by the derivative of this loob niya with respect to x. So pag with respect to x, kas wala na yung y squared at saka z squared mo kasi hindi sila function of x. So ito lang yung i-derive mo. So we have 2x. Okay, so yan siya. Okay, then the result is this one. Same for the partial derivative of r with respect to y and partial derivative of r with respect to z. Okay, so we have here the final answer of gradient of r. Okay, so we have here x over square root of x squared plus y squared plus z squared x hat plus y over square root of x squared plus y squared plus z squared y hat, and so on and so forth for z. Okay, or um, in here, as you can see, um, if we take a look on this result, both of its denominator have the same value. Lahat sila kay square root of x squared plus y squared plus z squared, or that is r, no? So it means that we can rewrite this equation here as x hat, y hat, or z hat over r. Okay, since r is equals to square root of x squared plus y squared plus z squared, or um, since this x hat here, y hat, and z hat is the position vector, just as what we have discussed previously. So we can say that r, yung may hat sa taas, over r na magnitude is equals to arrow pala to arrow, so is equals to r hat, where r hat is called as a unit vector. Okay, unit vector that points on that direction of this position vector here. Okay, bakit siya tinawag na po si unit vector? It's because its component is divided by the magnitude. Okay, and its value is approximately equal to 1 if we take the magnitude. Okay, so yan. So therefore, we can say that a gradient of this r, okay, which is equals to square root of x squared plus y squared plus z squared, is just equal to r hat, or equal to a unit vector that is pointing on the direction of this position vector. Okay? So del operator. So basically, di ba kanina yung gradient of t natin is equal to this one. If we factor out this t here, this t, which that t is a function, if we factor out that one, the remaining quantities here is called as a del operator. This is what I have said kanina. No? We call this one as a del operator. Okay? So the divergence, we have here the divergence, no? So how to get the divergence? Okay, so for you to be able to get the divergence, all you have to do is to follow this formula. We have kung meron kang vectors v, for you to be able to have its divergence, you will have you will have first the dot operation of that vector v with the del operator. Okay, so having the dot operation of that one, so you will find this equation here. Okay, so di ba yung definition ng dot kay ang i-multiply mo is yung component nila. So we have here component of this del operator along x hat is this one. Then i-multiply mo yun siya dito sa vx mo. Then same as for this partial of with respect to y, dito rin sa vy natin. Then i-add mo yan sila. Okay, so this is the divergence. Divergence na definition. Okay? So, geometrically, interpretation, the divergence of V is a measure of how much the vector spread out point in the from the point in the question. So, if you have a vector, okay, if that vector is diverges with respect to some point, it means that you can get its divergence using this equation, divergence of V. Okay, so for example, we have here, consider the function VA is equals to R, which is equals to x hat, y hat, z hat, and VB is equals to z hat, and VC is equals to z hat. So, if you will take the divergency, okay, so first kay, ito yan siya. So, first kay, will have the divergence of VA, yung first natin na vectors. So, what you will do is to multiply as what we have done here yung dito, okay? Idadat mo yung dalawa, yung del operator at saka yung vectors mo, then uh, for the dot na definition, you will have the multiplication of the uh, component. Okay? So, in here, ang component kay partial of with respect to x at saka yung x dito. So, kaya naging partial of x with partial of vx with respect to x dito. So, same dito, no? Gagawin natin kay partial of x or partial of v of x with respect to x plus partial of v of y with respect to y plus partial of v of z with respect to z. But since yung v of x natin is equals to x lang, so therefore here, papalitan natin to ng x, and then yung vy natin is y, so papalitan natin siya ng y, then yung z natin, v of z natin is z, so ito siya, papalitan natin yung z, kaya naging ganito. So these are equal to 1, 1, 1, so we have 1 plus 1 plus 1 is equals to 3. Okay? At saka kung i-graph mo yan siya, okay, kung i-graph mo ito first na function natin, so makikita mo that yung graph niya kay naka-diverge talaga siya, no? From the origin, it diverges along this direction. Okay? So therefore, tama lang na nakakuha tayo ng value ng divergence. Okay? Okay. So for the second vector, we have here v b is equals to z hat. So yung z hat natin kay um, a group of unit vectors that is pointing on the direction of z. So just like this one. So unit vector yan sila. Okay, that is pointing along the direction of z. So what will you do is to take the divergence of VB. Okay, so we have here once again, no, ang function natin kay z hat, we have to take the dot of this del operator with the VB. So, but since wala tayong x component and y component dito, so that's why nilagay natin dito kay 0. So, partial of 0 with respect to x, partial of y with respect to y, and partial of 1 with respect to z, kasi ang component natin along z is only 1. Okay? So, 1 lang dito. So, but since derivative of 0 is 0, derivative of 0 is 0 here, and derivative of 1 is also 0, so therefore 0 yung answer natin dito. And this is true because kung titingnan natin dito, so wala tayong nakitang divergence, no? Only the direction along the z-axis, pero wala tayong nakitang divergence. Okay? Now, dito tayo sa vector VC, which is equals to z hat. Ito yan siya, no? Ito. Okay? So, which is equals to z hat. So, if we take the divergence of that, so, yun nga, gagamitin na naman ulit natin yung definition ng divergence. We have idadot natin yung del operator at saka yung vector natin. So, partial of x, since wala naman tayong component along z dito, x dito, so 0 na lang. Then, same for y, wala tayong component along y, only the z is meron. Okay, so meron tayong z dito. So, partial of z with respect to z, but since this is 0, 0, and this one is 1, so therefore, these are all equal to 1. Okay? So, ibig sabihin, meron tayong divergence. So, kung titingnan kasi natin kung titingnan kasi natin yung graph ng vectors na to, makikita natin that the divergence the value will spread out along the y-axis at the direction of z hat. Okay? So kasi bakit? If you assume that z is equals to 1, it directed along the positive z, so ito yun siya. Then if you assume that z is 2, it directed along the positive axis pa rin, so ito yun siya. Then if z is equals to 3, it directed along the positive direction pa rin, so ganun siya, so on and so forth. And for the negative value naman, if you assume that z is equals to negative 1, so pababa. So if you assume that z is equals to negative 2, so pababa rin, so medyo malaki yung kanyang magnitude. Then if you assume that z is equals to 3, then mas malaki. Okay? So pababa yung kanyang direction. So as you can see here, parang ang implementation ng graph niya kay naka-diverge, no? Okay? So yan. So dito tayo sa curl. Sa curl naman is what we will do here is to take the curl of or take the cross product of the del operator with the given vector. Okay? So diba na-define ko na to previously on how to perform the cross product. Okay? So what we will do is to list all the direction x hat, y hat, and z hat here. And the second row is for the first vector, which is in this case yung del operator natin. So that is partial of x, partial of y, and partial of z. And then for the second rows naman, third rows naman is yung component ng v natin along vx, vy, and vz. Okay? And performing the operations, we have this equation here. Okay? So now, example, we can geometrically we can interpret curl of v as a swirl around the point in a question. So if meron tayong vector, kung meron tayong kung parang naka curl in, okay, or naka swirl or naka tawag dito, naka rotate, so yun yung tinatawag na curl. Okay, so naka curl siya along some point. So for example 1.2.3, so we have here, if meron tayong vector na VA which is equals to negative yx hat plus z plus xy hat, and VB is equals to xy hat, we have to for us to be able to calculate their curl, so we have to take this equation here. So we have the curl of VA is suggested by this equation. So we have to take the cross product of del operator and the VA. So once again, we list down the first row is the unit vector x hat, y hat, and z hat. Once again, I have just discussed this from our previous discussion. So for the second vectors, which is the del operators, we have partial of x, partial with respect to x, partial with respect to y, and partial with respect to z. And for the third rows, that is for the second vector, which is in this case yung VA natin. So that is negative y, yun siya, x hat, component along y hat kay x. So yun, component along z hat is wala, so 0 yung nilagay natin dito. So performing the matrix operation in that case, we will find that curl of VA is equals to 2z. Okay? So this is the graph of that curl. Okay? Then for VB naman, okay, so for VB, so ganun pa rin, yung VB natin kay x, y hat. So if we take the curl of that, so we will have the cross product of del operator and the VB. So once again, the first rows is for the unit vectors, the second rows is for the first vector component. So we have here the del operator. So partial of x, partial of y, partial with respect to x, partial with respect to y, and partial with respect to z. And the third rows is for the component of VB, which is the component along the x and y z component. So in this case, ang component natin along x kay 0, so wala 0. Then component along y kay x, then component along z is also 0. So if we take the matrix operation on this one, so we'll find this equation here. Okay, so this equals to z hat. Okay, so it means that meron pa rin tayong curl. Okay, so I think that's conclude this discussion. If you have any question regarding these topics, please kindly ask it to me right after this. Okay, so that wala tayong maging problema with regards to this discussion. So please don't share this. I have just used this for easiest of koan. But anyway, For our next na mga topics, we will just do our own materials para sa ating learnings. Okay? So, do not share this one. Okay? So, that's all. Assalamualaikum warahmatullahi wabarakatuh and good day.